So in this video class, I'm gonna explain to you, roughly speaking, the lab practice for the stage 2, which is about uniform rectilinear motion and uniformly accelerated rectilinear motion. So there will be two experiments done in the same device. What you're gonna see in the video is this device, which is an air track, this piece of metal, and then you're gonna see a glider on top of the track, which is just a little cart, and you're gonna see a strip of thermal paper like that. All of these things you're gonna see when Miss Elsa performs the experiment. So basically, what is this experiment about? This experiment, guys, is for you to observe uniform rectilinear motion and uniformly accelerated rectilinear motion, both types of motion that we discussed in the previous video. The air track functions in the following way. Basically, there's going to be air coming through the holes, these small holes in the track, because there's an air compressor attached to it, and so there's going to be air coming out of these holes, and what's that going to cause is that it's going to create a small air cushion, como un colchón de aire, on which the glider can glide, obviously, above it without friction. And what this is going to cause is basically that you're gonna be able to observe uniform rectilinear motion, because when you have friction, when you let's say that you have a, I don't know, whatever, a car or something, when you push it, you're gonna see that the car is gonna move, but it's gonna stop eventually. It's gonna stop completely. Why? That happens due to friction, guys, with the between the wheels and the ground. If there was no friction, the car basically could keep on moving forever. Okay, in a straight line. So in order to observe uniform rectilinear motion, we need to have this device working so that the glider can glide almost in uniform rectilinear motion with constant velocity. Okay, so on top of the glider, you're gonna see a little cable or a little wire, and what that wire is gonna do is spark every 0.2 seconds. That's gonna be the time, so let me write this down. The time is going to be 0.2 seconds between spark and spark. So basically, as the glider moves through the track in this direction, you can observe that the wire sparks at regular intervals of this time. 0.2 seconds, spark, 0.2 seconds, spark, 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 and so on. So that is what's going to happen, guys, in both experiments. In both experiments, with this one, uniform rectilinear motion and uniform accelerated rectilinear motion. In both types of motion, that's what's going to happen. Next, all we care about is the two strips of thermal paper with the dots that the wire left behind, which are these dots. Okay, for the experiment 1, we're going to observe something like this, that the points are going to be spaced almost equally, not not perfectly equal, because this is a real experiment, and in real experiments, you know, things work a little differently from textbook. But the distance from these 2 points and the distance from these 2 points and so on is going to be roughly the same. Why? Because in the first experiment, you can observe uniform motion in which the velocity doesn't change, and therefore between remember that between each spark there is the same amount of time. So we expect that the cart or the glider travels the same amount of distance every 0.2 seconds. So we're going to observe something like this. What is this x0, x1, x2, x3, etc.? These are the positions of these points. What you're gonna see Miss Elsa do is she's gonna measure the position of the first point, and she's gonna give it a value of 0. This is gonna be 0 centimeters. Then this is the position of x of the second point. It's gonna be the first. Well, we're gonna adopt the convention that the first position is position 0, okay, and then the second position we're gonna call it position 1, x1, and it's gonna be measured in reference to this point. So let's suppose it's 2 centimeters. Let's just suppose. Then x2 is gonna be 4 centimeters. Let's suppose. I'm just inventing these numbers. I'm not saying this is what you're gonna find. And then x3 could be 6.1 centimeters, etc. All of these measurements, guys, all of these positions are measured with respect to this point, which is your origin. That's why we gave it the value of 0. So what we mean by this position being 4 centimeters is that the distance from here to here is 4 centimeters. Okay, it's not the distance from here to here. No. What this means is the distance from here to here. What this means is the distance from here to here, etc. for the rest of them. Okay, now let me, I will talk about the experiment 2 in a moment. Now consider again the experiment 1. Once you have done this, what I want you to do is the following. I want you to construct a little table with the words or the columns interval and average velocity, just 2 columns. Interval 1, 2, 3, 4, etc. And let me tell you what the interval is. What is this? The interval is the first interval is this first bit of the motion, this first part. This is what we know as the first interval. The second interval is the distance from here to here, or this section of the motion. This is the third interval, the fourth interval, and so on. And what I want you to find basically as the objective of this experiment is I want you to find the average velocity during the first interval, and then the average velocity during the second interval, the third interval, and so on. How do you find the average velocity? Well, all you need to do, guys, is basically measuring what distance the cart traveled from this point to this point, like how much distance was there in here. Let's suppose, well, let's not suppose, what we have is 2 centimeters, right? So it's going to be 2 centimeters and divided in the amount of time from this point to this point, which is 0.2 seconds. So that's what you're going to do. You're going to divide this over this, and you're going to get, in this case, it's going to be 10 centimeters per second. That's going to be the average velocity during this first interval. You're going to do the same for the second interval. How do you find the average velocity? Well, this is the second interval, okay? And how much distance did the glider move? Well, it went from 2 centimeters, from a position of 2 centimeters to a position of 4 centimeters. So it traveled again 2 centimeters. So you're going to write 2 centimeters over the same amount of time, because between each pair of sparks there is 0.2 seconds. We do the same and we get the same average velocity. Now for the interval 3, which is this, 1, 2, 3. In this case, what was the distance traveled? The cart went from 4 to 6.1, so the distance traveled is 2.1 centimeters over the same amount of time. And whatever you have in here, that's going to be the answer for the average velocity for this particular interval. And I want you to do the same for all of the intervals that you're going to get. What must you observe? What should you observe? What you're going to observe, guys, in the first experiment is that these average velocities are pretty much the same, should be pretty much the same. Why? Because we're talking about uniform motion. The velocities through each of these intervals must more or less be the same. They're not going to be the same because this is a real experiment, but they should be approximately the same. And after filling the table, all of this table, you should get the acceleration. If you observe that basically there is no change between each consecutive pair of average velocities, okay, between these numbers, then you must conclude that the acceleration for this first experiment is 0, pretty much 0 centimeters per second squared. That should be your conclusion. Okay, very good. Now, that was the first experiment, guys. It's uniform rectilinear motion, and what you're going to observe is the cart moving smoothly over the track. Now the second experiment is pretty much the same. Pretty much the same. The core idea is still the same. The only difference now is that you're going to observe that the glider will be, well, we're going to attach a string to the glider like that. And the string is going to go over a pulley. You're going to observe what I mean in a moment. It's going to go over a pulley. And from this piece of thread or this string, there's going to be a mass, an extra mass hanging from some device. Okay, and basically what this is going to cause, this mass is going to cause the glider to move with uniform accelerated rectilinear motion. What it's going to mean is that it's going to accelerate the glider, and the glider will move with uniform acceleration. So the same is going to happen. The wire is going to spark it's a spark every 0.2 seconds, and at the end of the experiment, you're going to get this strip, and you're going to observe that in this case, the glider is going to leave points which are further and further away. Okay, like the distance between these 2 points is going to be much greater than the distance between these 2 points, and so on. Why? Because the cart or the glider is accelerating. It's accelerating. Now, you're going to do exactly the same as before. Once you have this piece of paper, I want you to do the same thing. For the first interval, find me, which is this first part, find me the average velocity. For the second interval, find me the average velocity, and so on for the rest of them. What you should see in this second experiment, after you get the average velocities, you must observe something like this, that the average velocity will increase. Let's suppose that during the first interval, the average velocity is 1.5 centimeters per second. Let's suppose that this is the final conclusion or the final result for the first interval. Okay, since this is accelerated motion uniformly, what you should see more or less is that this quantity increases by the same amount. Okay, let's suppose it's by 1.5, more or less. You should not see exactly that, but more or less. For example, we may see something like this, 1.5 and then 6.2. Okay, if you notice, guys, the change of velocity during the first pair of average velocities between this and this, the change of velocity is 1.5 centimeters per second. And then between this and this, how much was the increase? The increase is going to be 1.6. Okay, and then from this and this, once again, the increase is 1.6. And then maybe from this one to the next one, you're going to get 1.4, etc. So you should observe more or less the same change in velocity by the same amount. On average, in this case, in this hypothetical case that I'm telling you about, that change of velocity is 1.5 centimeters per second. That is the change of velocity. In how much time does this happen? Like the velocity changes from here to here in how much time? In this time, right? In 0.2 seconds. So once you get this done, you're gonna fill the table and you're gonna get the acceleration. What is acceleration? Remember, it is the change of velocity divided by the change in time. And the change of velocity in average is 1.5. Let me move this. 1.5 centimeters per second, and the change in time is 0.2 seconds. You divide this over this, and therefore you will be calculating the acceleration for this second experiment. The acceleration for this second experiment should not be 0. Should be something different than 0. So that's what you want. That's what I want you to do, guys. It's basically measure the average velocities for both experiments, the average velocities for each interval. Remember, these are the intervals: first, second, third interval, first, second interval, third interval. You're going to measure the average velocities, and at the end, with that information, you're going to calculate the accelerations of both motions. And you will find that the acceleration for the first one is 0, meaning that the velocity is constant. And you should find that the acceleration for this one is different than 0, because this is uniform accelerated motion. Okay, so that's how the experiment works, guys. And you can start working on it right away.